So guys, now let us start with the discussion of data structure and algorithm required to design and implement routing table. So before going forward, let us make ourselves familiar with some keywords. The keywords are prefix, mask, and wildcard. So let us get ourselves familiar with the definitions of these keywords. So let's say you have an IPv4 route as an example, which is 1.2.3.4/24. So with this example, the prefix is nothing but the actual IP address itself. So here the prefix is 1.2.3.4, and when this prefix is represented in the binary form, you will get 32 bits. This is the first octet, this is the second octet, this is the third octet, and this is the fourth octet. Here octet means a byte. Alright. So prefix is nothing but the actual IP address part of a route is the prefix. Then mask is the 24. In A.B.C.D or CIDR notation, we express the mask as 255.255.255.0. This 24 actually means that the first 24 bits in the binary representation of the mask is 1, whereas the last 8 bits would going to be 0. Alright, so when we say /24, it means that the first 24 bits of the mask are all ones. And of course, the mask length is always 32 bits and the prefix length is always 32 bits. This length is fixed and constant for IPv4 addresses. Then comes the wildcard, which is exactly opposite of mask. If you flip the bits of the mask, then you get the wildcard, as simple as that. So in CIDR notation, the wildcard is expressed exactly opposite to that of the mask. That is, you replace 255 with 0 and you replace 0 with 255 and so on. In the binary notation, all the ones will be converted to 0 and all the zeros will be converted to ones. So this is what wildcard is. Alright. Then comes the effective prefix. Effective prefix is nothing but you are trying to view the prefix and the wildcard as one single logical thing. So in effective prefix, you take the bits from the prefix and you take as many bits from the prefix as equal to this mask number, which is 24. So you have taken 24 bits from the prefix and the remaining bits will come from the wildcard. So in a wildcard, in whatever positions you have 1, just replace those 1 and represent those 1 by X. So here X represents don't care. Alright. So in the wildcard, add those bit positions where you have 1. Those bit positions are don't care. And in the mask, those bit positions where you have 0, those bit positions are don't care. So you have don't care both in mask as well as wildcard. The only difference is that in the mask, don't care is represented by bit 0, whereas in wildcard, it's the bit 1 which represent don't care. In effective prefix, the don't care is represented by a symbol X. So note that effective prefix is used to view the prefix and wildcard together for easier human understanding purpose only. To store the effective prefix in computer memory, you still need a prefix and wildcard together saved in separate variables. Alright, so in a separate variable, you store the prefix part, and in separate variable, you store the wildcard part. And combining these two, you will get the effective prefix. Alright. So in the remaining part of this course, we will going to keep on saying the word prefix, the wildcard, the effective prefix. So it is important that you get familiar with the vocabulary that we will going to use in this course. And you can see here is some URL, which is nothing but it is a nice IP calculator present online. You can always use this calculator in order to convert the IP routes into its binary form and vice versa. So this calculator will help you a lot and you can bookmark this calculator in your browser.